Good evening, everyone, and welcome to the first of our new series of Rotorcraft Knowledge Lectures, hosted by the Rotorcraft Specialist Group of the Royal Aeronautical Society. For those that I haven't had the pleasure to meet just yet, I'm Richard Brown, the current chair of the group. I thought I'd spend a little bit of time, seeing as this is the first lecture, explaining just what the aim of these lectures actually is. And it's actually very simple. We're simply here to learn from each other. The rotorcraft field is vast, and the range of expertise spans from operators to pilots to regulators, through to engineers, mathematicians, and theorists. And certainly during my time in the industry, at least, I've come to realize how deficient my general knowledge is regarding rotorcraft. Like many others, I certainly don't know my H-TORs from my FAR-25 from my lagging hinges. And indeed, it's incredibly easy, I think, for us to become siloed and compartmentalized in our knowledge and thinking. And this siloing can only be to the detriment of our ability to communicate and to advance as a community in a time, perhaps, when we can little afford this fragmentation. Also, talking of silos, it's the case at present, and certainly 10 minutes scrolling through social media, I think will support my claim that elements of our community now live quite comfortably within their own little echo chambers, always hearing from the same old people with the same old message, pushing the same old ideas. And we need new voices, we need fresh ideas to engage our intellect anew if we're not to stagnate and become complacent in our own worldview. And these lectures are intended essentially as a refreshing and invigorating antidote to intellectual stuffiness and mental laziness. So I encourage you to take part and contribute. But please remember that we engage here in the spirit of learning from each other and with each other. So please be civil, be kind, give more than you take, and of course, remember who controls the mute button. So in that vein, I'll say no more, but instead I'll move on to introducing our speaker for this evening. And I'm very pleased to introduce Stephen Moroney-Lewis. Now, Stephen is a senior commercial airline pilot with over 20,000 hours of flying experience and a long-haul career at Virgin Atlantic Airways, where he was a training captain on the Airbus A330, the 340, and the 350. Now, following a car accident in 2021 that resulted in the loss of his medical certification, Stephen transitioned to a ground-based operation and safety role. And he currently works within Virgin Atlantic's fatigue risk management team, and is chair of the Flight Operation Liaison Group's fatigue subgroup at Virgin Airways. Now, his first degree is in engineering from Christ College, Cambridge, where he specialized in aerodynamics, fluid mechanics, and operational research. And alongside his current industry roles, Stephen is in the final year of study for a master's degree in aviation safety management, risk and regulation at Cranfield University, which is largely why we're having him speaking to us tonight. And indeed, tonight he'll be talking to us on his work in developing a systematic approach to integrating advanced air mobility into the UK aviation infrastructure. So with no further ado, I'll pass over to Stephen and we'll get his slides on the go and look forward to a very interesting presentation.
So thank you, Richard. So I'm hoping that you can see our first screen.
You can see it loud and clear.
Loud and clear, sounds good. So welcome everyone, and again, thanks, Richard. This evening, I'm hoping to bring you the results of some research in which I was involved with a team of my colleagues studying at Cranfield University. The module was about managing emerging safety issues, and we were tasked with looking at advanced air mobility, not about the actual technologies, but the safety issues that are raised as a consequence of the introduction of novel technologies. So we're going to talk about the literature review we did, an overview of the methodology we used, the survey and interview results, a little look at template analysis, which is the way of doing qualitative analysis of text, written data, and the conclusions and recommendations that we drew from the data that we collected. So this was the scene in December when our results had to be first presented to our lecturers and module leaders. Some of you may be familiar with Graham Braithwaite, who's the Director of Aerospace and Aviation at Cranfield. He was a head drawer. And this list here is the group of my amazing colleagues who contributed to this project. Some from the CAA working in regulation, some from airlines. There's one pilot in addition to myself and an engineer who works in compliance for a major airline. And one who couldn't really tell us what they did because it was too classified. I think it involved something that's painted grey and flies very fast, but they couldn't really tell us about it. But it's a group of people who have significant experience in the aviation industry. So this was how we put our research into context. Um, we're, we were considering national aviation authorities and how they would coordinate manufacturers, operators, navigation service providers, and local authorities in the environment of this new advanced air mobility to integrate eVTOLs into controlled and urban airspaces. So with the subtle differences there, and how a disruption to established equipment and processes might affect safety across the whole system. So the challenge is to balance that innovation with systemic safety. Um, and we had just finished learning about socio-technical ecosystems, so we were all very pleased to apply that knowledge. And I'll discuss how the UK was chosen as our main source of data because we got the best engagement from there. So essentially, we're looking at the mix of technology, hardware, software, and real people, or liveware, as it's sometimes referred to, and how that all fits together in a systemic safety environment. So our research question is here. With emphasis on the coordination that goes on we made the assumption that it was an integration of the new technology rather than scrapping the old and starting again with a new, which sometimes is a desirable option. But we felt that integration is what's needed because airline pilots don't like to change what they do very much. And overall, looking at systemic safety performance across the existing air transport system. That led us to refine that question or alter the emphasis of it so that we could add some sort of critical evaluation of the situation. So we want to look how each stakeholder feels they're ensuring the safe integration in an attempt to evaluate how their efforts are being coordinated. We wanted to look at the issue from as many different angles as possible. So again, critically evaluate using people's subjective opinion, actual examples, overall impressions, some of the less tangible aspects surrounding this topic. And we started with a literature review. All good research starts on finding out what we know already. And this little table, I hope you can see it at that scale, sort of shows the majority of literature comes from 2023 onwards, and that's evidence of a new and forming industry. And so lots of the documents were just hot off the press. So with what we described as an immature evidence base, but it provided a good foundation for our empirical work. It was a cross-section of academic literature, regulatory literature, and industry sources, and down to glossy adverts for various vehicles. But that collection of literature sort of allowed us to look at the key concepts involved, that we were looking at a new model of air mobility with different power trains and sources, the vertical takeoff capability. The literature started to highlight some gaps, vertiports, charging, digital systems, and concerns increasingly about cybersecurity, with topics transferring from the drone world into advanced air mobility as well. And the challenges that integration might produce with battery safety, the way energy is stored and the limitations of that energy storage, that there was no mature certification framework, um, the complexity of operating low level in a crowded environment, how the public were affected by this new um, evolution in aviation, the noise, the equity of the situation, whether it applies to everyone, and privacy concerns, and again, the growing cyber vulnerabilities. So we had a varied amount of literature, and we that our next step was to try and get some information from people, and we set up an online survey um, to get some information from people in the field, the working groups we might be examining, some perceptions about preparedness from those in the industry, and whether or not that individual would be prepared to take part in our interviews, which was part of our questioning. We advertise on LinkedIn and through professional networks. We all seem to know someone who was involved at some level, whether it be part of the regulator or members of the EV senior leadership group, which is one of the groups we were looking at, or journalists with a particular interest. We started as the idea was a three-country comparison, but one of our team was based in Dubai, another came from Poland, and we thought we'd try and use those contacts to get some information. But the response from outside of the UK was very diminished, and we were kind of surprised about that. But persuading people to contribute some information proved to be quite hard, except from the UK. So we're obviously good at talking about things. So we wanted to make a qualitative study focused on the UK only, because that's where the rich data was. So we saw that people were willing to talk and describe things. So we wanted a way of capturing that data. Um, uh, Quantitative research in kinds of percentages of people doing this and that didn't really apply to this situation. So we chose a template analysis, which I'll talk about in a bit, and we use that to integrate and analyze the data from the literature review, the initial survey, and the interviews which we conducted. This is kind of the process for the template review. It's a style of thematic analysis. It's a popular use in applied research. It's scalable, it's flexible. It allowed us lots of freedom to collect data in interviews and from literature and incorporate that in to our research. Well, we conducted 10 interviews. They were lasted about 45 to 60 minutes. And when transcribed, the came to well over 70,000 words of data. The auto transcription that we used in Teams didn't cope very well with some of the industry specific terms. So that gave rise to some entertaining phrases in our text, but we had to go through that and correct them all, looking back at the recordings. And that helped us, in fact, familiarize ourselves with the data and continue with the template analysis. A preliminary stage, using the data from the literature review, we came up with what they call them a priori themes. So it's like, how can we categorize what we've learned and what themes can we put them in? And then using a collection of sub-themes to fit into the themes, we can cluster things together, move things around, and generally evolve the template that we're going to use to code all our data. And the preliminary stage looked really interesting, and it got even more as we developed the template. While we were doing our interviews, we found out that the CA had released the CAP 3141, which is the STPA-based safety analysis of VTOL operations, and that was a great contributor, and we could incorporate that as we were conducting that. And the final template becomes sort of like a map of your thinking about what the data is. It allows you to look at what the key things are in the data. At some point, we had to narrow down to two or three people making the choices about the themes. Because it just got too complicated with everyone contributing, and then we used the other people as like a cross check. They kind of looked and checked our work, and it seemed to be in agreement. So that was easier. It ended up with two pilots chatting about it. So that was quite a nice evening or two with some post-it notes. And essentially, we then came up with our themes, our codes, and I will show you next a little example. I don't expect you to read this, but there's kind of the spreadsheet that we produced. On the left-hand side, there's the theme, a description of it, codes of the sub-themes, and then we looked for evidence in the text to sort of illustrate the level of agreement with that theme and the level of disagreement with that theme. And then the final stage was to use that to make conclusions and recommendations, which we'll talk about later on. I did notice in preparation for this presentation, there was a comment in the text that someone suggested that as part of a stage process that we should look at cargo operations, and that didn't actually appear in our research, but I'm going to zoom in on this if I can. One of the themes is staged incremental integration. And so the beauty of this template analysis is that you can, new data comes in, you can fit it into your existing framework or develop your framework to accommodate the new research to reflect what new information you're finding out. So our themes that we came out, there were 7 themes. The first one was the staged incremental integration that we talked about. A quote that we had, VFR can get us started, but if you want real networks, you'll need IFR procedures into these vertiports. So again, the idea is that you sort VFR out, then your next step is the IFR. Or as we've seen, let's start with cargo ops or medical transportation or emergency services and then move on to the next step. It's that underlying theme that people think, well, let's see what we can do first and next, and then what's our ultimate goal. Another theme was the role of the regulator in the UK, the CAA, how the CAA is perceived and how it should act in enabling safe advanced air mobility integration. A quote we got was the regulator is the backstop. People look to them when something goes wrong. So that was definitely an underlying theme that the regulator should be the safety anchor. And then we found evidence about governance, leadership, and fragmentation. As a quote, there are lots of green shoots in different directions, but it's not obvious how they all fit together. A little gardening metaphor there. And another quote was, we have all these groups, but I couldn't draw you the wiring diagram. And that's one for electrical engineers. But the message is, too many groups with weak connections can lead to fragmented governance. Theme 4 was the need for global alignment, international harmonization and competitive positioning. There was a quote, we can't afford to invent our own unique flavor of rules. It would kill the market. And from the literature, we saw that the current UK position is to align where it is in the UK's interest to do so. We had a quote from someone saying that German firms have told us they won't look at the UK unless they know it's aligned with the EASA. So we also saw some evidence that being involved at an international level does take some resource as well. So there was a challenge of that alignment, but it was deemed to be crucial. Another theme was that local authorities, communities, public acceptance, the quote to illustrate, or one of the quotes, councils can close down the eVTOL industry locally simply by refusing planning consent. So they do play a vital role. Another quote was, some councils are barely coping with existing transport issues, let alone eVTOL. Residents will quite reasonably ask, is this just a toy for rich people flying over my house? And then if it looks like helicopters for VIPs, people will react in the same way they do to helicopters now. So that theme was that local authorities and the public the engagement of those is vital for success. The last two themes, safety assurance, novel hazards, systems thinking. We have an expert with us, Richard, about the vortex ring state, just uh, novel items or the way items interact to produce novel phenomenon. We had a quote that said, batteries change the whole firefighting problem. We can't treat them like conventional fuel fires. And as I mentioned, the systems theoretic process analysis report came out, and it did show that that's a useful way of looking at safety. We had a quote that's saying STPA has helped to see where responsibilities cross boundaries. And someone else said most of the real risks are at the interfaces between aircraft, vertiport, local responders, and airspace. So we lumped those together in a theme that there is a system level risk along with the new safety risks of individual items. And then finally, um, we're going to describe this as an integrative theme because it pervades into some other themes, but is a standalone thing as well. It's resourcing, skills, knowledge gaps. Um, a quote we got, we're vastly under-resourced for the expectations people have of us in this space. That was from a regulator. And someone else said, it's hard to justify conference travel on a one-year budget when work is inherently long-term. So um, there was definitely a theme that the regulator needs sufficient resources to perform uh, sufficiently, and this new integration produces a very high workload for them. So a lack of resources is obviously a problem. So these are the themes that came out of the template analysis. The next step was to make recommendations based on those themes. However, I'm going to put some caveats. If you think back to our research question and aim, we were wanting best practice for all national aviation authorities, and yet we only collected data from the UK. We did think that despite this, it was still worthwhile making a start. One of our research objectives that contributes to fulfilling the research aim was to develop evidence-based recommendations for national aviation authorities. And we thought we would stick with that, even though we just got data from the UK, just bearing it in mind. We did see some evidence of a variation globally to risk tolerance. So some of the things might be taken on board in slightly different ways around the world. But we had the themes, and on one level, so what if you got the themes after doing the research? To me, the recommendations give meaning to the research. What use are they if we don't actually say something that can apply in the real world? Um, uh, and they are very much idealized. There are wouldn't it be good if that you might be able to talk about. There will be challenges, but our theory is the debate has to start somewhere, right? And this seems like a good place to do. So here are our recommendations. We put them in three categories initially: governance and strategic, stakeholder coordination, and safety and enabling. And we start with coordination and planning from the highest level of government for the building a national advanced air mobility integration board. The phased roadmap, make it explicit. So we have the idea of crawl, walk, run, and the steps that you need to get to where you want to go. And we have a line, unless there's a good reason not to, and share that reason of why you don't want to align globally. I'll talk about each recommendation in turn shortly, but just could continue the overview. Uh, we want to actively create and nurture a symbiotic relationship between regulator and manufacturer, but obviously that has some caveats in itself. So there needs to be a design to that relationship. And again, we'll talk about that shortly. 5 is elevating the role of local government. LAs have the final go, no go decision because it's in their backyard. So they need to be on board. Um, and in safety and enabling, we have the complexity of emerging system requires a change to the way we do safety, perhaps. Um, and the dedicated and secure comms channels for electronic conspicuity and trajectory planning. And finally, secure funding. That's the key to stability. So that was part of our recommendations. So our first recommendation about the National Integration Board. And as I said, it's coordination and planning from the highest level of government. So there needs to be government representative, regulator, there needs to be people from the manufacturers and operators, and all the way down to infrastructure providers and academia, in fact. This board needs to have a clear terms of reference and structure. There can be subgroups doing specific tasks, but all the work should be coordinated through that board. And the board has the authority to make decisions with the funding behind it, and representatives from government, as I say, not necessarily chairing it, but definitely they're involved and kept advised as to what's going on. EASA is particularly good at a roadmap, but I did see a good one from NATS talking about their plan for this integration. But our recommendation is for the National Advanced Air Mobility Integration Board that we've just created in our ideal world, that it publishes and updates and continues to update a roadmap with realistic timelines, evidence-based thresholds for progression, so that safety regulation is based on data rather than being market-driven. And from the other side, I guess investors have a better idea of the prospects and timescales that we expect in that particular geographical area, where the NAA is responsible. And our topic of aligning globally by default, unless there's a good reason not to, and sharing that reason. We had some feedback from some academics suggesting that this might be a challenge to innovation. If there's a way it's done, you have to do it that way. So there are risks with this recommendation, but I think that risk can be managed with clear and open communication, because if there's a reason why you don't want to adopt something, and that is published, then people might think, oh, actually, that's not a bad idea, and let's all adopt that. So I'm hoping that isn't such an issue, and that addresses their concerns. Now, this is the one that I think needs some serious workshopping. Our recommendation is to prescribe the rules of engagement in the regulator-manufacturer relationship, so that it facilitates innovation and produces responsive regulation, but protects the individuals involved. So it's actively creating and nurturing this symbiotic relationship, whether we learn together. We have to accept that the regulator needs a relationship with the innovators, but there have to be rules, terms of engagement, and a transparent framework for that operation, as I say, to prevent rogue things happening and to keep everyone on the straight and narrow. So that's our recommendation to do with that relationship. And we are all for elevating the local government. This is the democratic part of our recommendations. Local authorities represent the people. They are directly voted by the people, and we need to bring public along with us in this evolution. As I said, they have a go, no go decision, because if planning consent doesn't happen, we can't progress. So they need to be educated about the benefits and potential challenges of this new operation. But hopefully, when they're clear of challenges, we can work together and meet those challenges, and then reap the benefits. Recommendation 6 is the complexity of the emergent system requires a change in the way we do safety. We talked about the system theoretic process analysis. There's other things of functional resonance and other things that we learned about during our course. We can no longer rely just on slices of cheese for our understanding of how safety works. That model is great, the Swiss cheese model, but complex systems can create failure outcomes even when their components are working correctly. So it's the interaction of these components that might cause unpredicted and potential unsafe outcomes. Um, STPA is not a quick process, but it does encourage lots of communication between all the stakeholders, and it's a proactive safety methodology. So I think it has some great value. It needs some time investment, some education on how people get to use it, but I think it could be a very valuable tool in the future. So there wasn't a lot of evidence to support this recommendation, but we suspect that's because not many people have thought about it much or don't feel empowered to do anything about it. But it did come up. We do have some evidence for it. A dedicated and secure comms channel for electronic conspicuity and trajectory planning. Standardized comms channel that will work close range for coordination. It'll lead to improved safety from the early stages and help produce cyber resilient operations. It's like a designated and protected communications for well, all aviation. But I don't think we have that, and our recommendation is to get that. And our last recommendation is we found evidence that the amount of and confidence in the funding of a regulator is a threat to safety. Secure funding is the key to stability, and instability is not good. So whether it's an annual review of a 5 or 8 year funding schedule based on a tax on operational costs or the number of staff involved or whatever is concluded, there needs to be certainty that there will be consistent funding available for at least the medium term for the regulator, so that people can actually commit to developing new technology. The vast majority of our recommendations rely on improving and maintaining open, accurate, and timely information flow between a large group of stakeholders. What could possibly go wrong? But essentially, it's all about communication. The only one that isn't or doesn't seem to be initially is the one about funding. But we could argue that in order to secure successful funding arrangement, you would need to communicate between government, regulator, bringing interested parties into the discussion. In the UK, the CAA's charter, last time I looked at it, said that it should be largely funded by the entities that it regulates. So it would be good to have a good conversation about that, I suspect. My understanding is what Richard, our host this evening, wanted is to start the conversation about this whole topic or set of topics, and to make sure all the necessary parties are in the room for that conversation. The recommendations from our research suggest that he's on the right track. The safe integration of emerging technology relies on a good flow of information from all parties and requires a combination of governance, leadership, and facilitation to coordinate all the necessary processes. So what next? So we could continue our research. We have a template. We can evolve it as new information comes in. I do have an online version of the questionnaire we use for the interviews. So we could distribute that among stakeholders. Everyone on this conference today could fill it out with full and frank answers. And I'm going to suggest we use AI once we have a load of text like that. That would be a good idea to use that to perform more and expand our template analysis. And whether we can further develop that, adding focus to some recommendations, or maybe making even more general ones, depending on the response we get from around the world. But that can only add to our insight into the complexity of the issues. Or we could expand the scope of our research and consider that autonomous eVTOL is the final goal, and we need to expand the literature review and the timescale and the field of stakeholders, and revisit the template from that side. So this is where my presentation will end. As a group at Cranfield, we were hoping that these recommendations might help with maintaining or improving even the safety record of the aviation industry as it moves into the future. Simple maths says that given a rate of incidents per aircraft movement, any increase in traffic produces an increase in incidents. And so it has to be said that the last 18 months have not been great in terms of casualties. But we always need to do better. And if we work together, I think we surely can. So thank you very much.
Thank you very much for that, Stephen. That was fascinating and all-encompassing. Okay, so we can move across to questions now. Now, just as a matter of procedure, if you've got a question, pop it in the chat box, and I will try my best to convey the question in some form of consistent fashion to our speaker. If you'd like to join in the conversation as well, just raise your hand, and I will unmute you from this end. It's easy enough. Okay, so if I look in the chat box there are a few questions, and I'll order them slightly differently from what we've got there essentially. But yeah, okay. So you've looked very much ahead to a new technology and how that new technology might be integrated into the existing air transport framework. But Alan asks a very good question. Alan Pritchard asks a very good question. Why restrict this to the VTOL with an E in front? Surely there are other parts of the air transport industry that could benefit from a similar revision of some of the procedures that we currently use to govern air transport.
Absolutely, I completely agree with that. Obviously, we had a scope that we were given as the starting point of our research. We were looking at emerging technologies and managing the safety involved in that. But I mean, CAP 3141 that looked at existing operation as well, didn't it? And that found, after all this time of operating, it found quite a few gaps. Was it 17 gaps that needed to be sorted quite quickly? Um, so yes, I completely agree, and it does. And I guess that takes funding for someone to research, and I feel that that's a necessary thing. And as I say, if we can change the way we do safety to incorporate this new STPA, I think that's to everyone's benefit.
You seem very, very positive in terms of STPA. Would you like to elucidate us in a bit more detail what it actually entails, how it works in practice?
Um, yeah, so you look at all the interactions that can happen between the various systems, and you look at the inputs between them, and what happens if you get the correct input, but it's slightly late or slightly early, and if you get a false input, and then what the consequences of that would could be. And you basically work through a lot of different options, and it takes a lot of time, and you consult with all the experts in the field, and produce a set of responses that and highlight the unsafe responses, and then what controls you can put in to stop that happening in the first place. So it's a topic, a lecture. It's a 2 or 3 hour lecture, and a goodly long time to get used to the system, I think. But
Now, if I recall correctly, it's an outgrowth of the original work by Nancy Leveson, isn't it, at MIT?
yes,
On Stamp, I think the original version of the model was.
yes, yeah.
And if folk are interested, if I recall, there's a huge website of resource over at MIT, and there are yearly courses that you can go on. I think most of them are online, so that you can attend from almost anywhere in the world and so on. So if folk are interested in that, then the world's your oyster to a certain extent. And yeah, I think the tools are there for integration into folks' niche areas.
Mm. There's various bits of software to help support you do it, but for me, its main well, one of the main benefits is that it gets people in a room talking about the situation to try and
Mhm.
find order in that complexity, and
Yeah.
I think that there's the value in that.
Now, the one thing that's always troubled me about methodologies like that is essentially SDPA needs SDPA of its own, doesn't it? There's almost like this, in a sense that if you're doing a safety analysis, it's always restricted by the extent of your own imagination as to what can possibly go wrong.
Yes,
And if
yeah,
there is a whole branch of catastrophe that sticks over to one side, SDPA is not going to discover that for you. It's going to give you a process whereby you can articulate those issues, but if you know that they're going to be there, but it doesn't actually help you winkle out hidden failure modes or modes that you can't think of from the get-go, if I'm
Yeah,
correct.
but as you're encouraging people to get around the table and talking about eVTOL, the more people you have in the room, the more ideas you'll get,
Mm,
and things that you might have overlooked yourself, someone else is providing it. That's the beauty
mhm.
of communication and working in a team.
Yeah, good answer. Are there many folk working in the eVTOL field and simultaneously applying SDPA or STAMP that you know of?
Um, I don't know that it's being used outside of academia. That the
Mm,
CAP 3141 was done at Warwick,
that's
I
right.
think, and uh, I think that's it hasn't left the universities yet. I think that's what the issue is.
Mhm. Okay, might be worthwhile looking through the list of presentations at some of the last workshops to see if there's anything of interest. And
Mm.
if anybody on the call is interested in presenting on SDPA, then by all means, let's listen in more detail. Um, I think Correa decided that probably addresses your question to a certain extent, which was, can you give your opinion about the use of SDPA to deal with this kind of system? And I think if I paraphrase you in a sentence, you're very positive about the ability to apply these systemic level safety tools into a system which is essentially a carbon copy, or it's effectively designed in terms of that sort of structure.
Yes,
Mhm.
yes, I am.
Alan reminds us that most issues occur in the interface between physical elements. I'd also say in terms of the interface between human elements. I think you'd agree with that, Stephen.
Hmm. Um, I just looked at it now. Yeah, and um, a lot of people, when they're looking at safety, look within the boundary of what they can control, and so anything beyond that boundary is not their safety problem. But
Mm,
actions that happen across the boundaries, where transfer is control, sorry, control is transferred, or the way the things interact, that can be the weak points or the more challenging points.
yeah, much within the scope of the series of lectures as well. Let's try and remove some of those barriers
Yeah.
and failures of connection and see
Yeah,
what we can do.
but of course, as you increase the boundary of your system, you're increasing the complexity of the system that you're looking at because you're making it bigger, and
Yeah.
that's where the issue lies, I think.
Which brings us quite neatly, I think, to Tim's question, which is essentially what happens if we do expand the scope of the study out of the urban environment and the controlled airspace, and we try to extend the analysis into non-urban and uncontrolled airspace.
Mm.
What additional complications does that bring into the picture?
Um, well, I think probably part of the issue is that once you move out of controlled airspace and you're in urban airspace, you need another control. You need another form of looking after things. So
Mm,
you're basically expanding the controlled airspace, I think. If it's an area that people are using a lot, then then you need some kind of control, and that's from we had data about that's where the ship-to-ship communication, the shortwave protected. Sorry, I say shortwave, I meant short range.
mm,
Uh, um, Communications frequency works quite well for conflict avoidance that can be
mm,
done
mm, mm.
outside of the space.
Yeah, so I'm guessing it turns the control problem from a sort of largely systemic, perhaps ground-based system to being one more localized to individual aircraft to aircraft communications.
Yeah, yeah, and I think that needs to be developed at the same time
Yeah.
within the small within controlled airspace as well. To be honest.
Mhm. Yeah, I mean it's very interesting the whole idea of things like how what's the collision avoidance system TCAS that's used on airliners.
Hmm.
So it's essentially built on the basis of one body interacting with another. Um, Now we're talking about a system where we have thousands. Well, that's probably unrealistic. We're having dozens of aircraft operating within a very confined box.
Mm.
How sort of dual body systems or systems designed for dual bodies now work for multi bodies,
Mm.
and how tractable that mathematical problem becomes. And okay, if we had an applied mathematician on the call, they could perhaps make some comment on that. But to a certain extent, I mean, this makes me think along the lines of there's a certain level of wishful thinking, and there are a set of recommendations that we might like to apply. But one thing that really interests me is how Isaac Newton steps into this. He's a grumpy old guy who died hundreds of years ago, but his rule is absolute. If you don't correspond to his rules of motion,
Hmm.
you cannot design a system which can circumvent those.
Mm.
So I wonder if there are not some physical limitations that we should be talking about at some stage to designing the ideal system that we would like in practice.
Yeah, yeah. So, um, I mean, our thoughts were not so much about the technology itself and the nitty-gritty of the systems. That these were like overall safety recommendations. Um, but yeah, they have to run in parallel, don't they?
Mm.
Information developed in one side needs to be exchanged with that on the other.
Yeah, I think one of the issues that we've been seeing is that some of the proposals that they've been put forward by some of the regulators are not necessarily consistent with the limits on the physical behavior of the system. They
Mm.
do tend to be a little bit utopian in some aspects. And so how do we bring those people into the room in a proper way that they can actually integrate with the safety issues and the definition of the system so that everything works in a harmonious but physically realizable form?
Mm.
Okay, so Jack Allen from Vertical then asks, which of the recommendations you think will happen naturally or organically, and perhaps which are more likely to happen, essentially, I guess, on their own, and which do actually need more incentivization? He mentions the interaction between the NAAs and the OEMs, which I think is already, as he points out, is already a priority for most manufacturers. But perhaps even some of the local authorities, as he points out, haven't even started to consider these vehicles flying over there, over
Yeah,
their, their
well,
state just yet.
that is true. I'm guessing that we think that they all need some kind of guidance. I don't think they will happen naturally
Mm,
because even though the relationship between manufacturer and regulator is a priority, it might be a priority for the manufacturer because they want to know how they're going
mm,
to be curtailed, probably. But I think our recommendation is not just have a relationship, it's have a designed relationship. It's
mm,
have some rules, have some transparent ways that we think the regulator should interact with the manufacturer and vice versa, so that it can be applied globally, so that people aren't bypassing things in different places or uh,
yeah,
changing that the nature of what we believe a good relationship is. And again, it's to protect the individuals that are involved, but it's also to protect the overall safety of the system. So I'm I don't think any of the recommendations will happen naturally to the extent we want them to happen, if that makes sense. Um, but yeah, there's at least one local authority that's very keen on advanced air mobility, and but again, they don't have the resources to go and generally they don't have the resources to go and learn about this and visit conferences and do all that.
mm,
Um, so I think uh, my answer would be we need the governance to make sure that those recommendations are applied fully, not let some evolve however they evolve.
yeah. I might push you to be more concrete about how you see that relationship developing. It's one I think that's pivotal, especially the NAA OEM relationship.
Yeah.
And you could argue that in certain parts of the world we've seen various different manifestations of that relationship, some of
Hmm.
which might be judged as fairly pathological, some of which we might consider as healthy, and some
Hmm.
of and some in between. Any
Yeah.
comments on that basis?
Well, yeah, I guess what I'm suggesting is we want a SARP for it. We want
Mm,
this is how you do it.
mm,
This is the instruction manual for these are my terms of engagement between regulator and manufacturer, and that empowers the regulator to say, no, this is how we're going to play this, and this is how we're going to work together. And I think that could be good.
Yeah, I think I
Might
might agree with
liberate.
you. I can see. I mean, you can see cultural issues materializing here, though, right? I mean, so FAA, CAA, EASA have a very, very different internal culture
They
and a
do.
very different kind of ingrained way of interacting with the outside world. So yeah, let's see how one can develop an internationally agreed uh, open open source
Yeah.
structure for integration between the NAs, especially and the OEMs and that place. I think it's a great idea.
So at one point I mentioned the workshopping idea.
Mm,
I, if these aren't finished and applicable, then they need to be developed, and you'd only do that by engaging with people and discussing what is feasible,
mm,
what is practical, and what is best practice. Um, so that's what we were thinking. Part of our one of our interviewees said that. So, for example, in the States, if a helicopter crashes, it doesn't even make the news. But
mm,
in Europe, in the UK, it's look, this has happened. This is terrible. So there's a different attitude to losses,
yeah.
which is hard to understand, because maybe we it's just different value sets and different attitude to risk. But so is it then possible to create something that applies globally? Um, I think probably it doesn't hurt to aim for the best practice and spread it around, basically.
Hmm. Hmm. Yeah, I imagine politics and so on will heavily influence the eventual outcome of any initiative like that, but that doesn't stop us from trying, I don't think.
I think that's
It's
what I'm
if
saying.
if you'd like to comment on sort of, for example, the EIP, the eVTOL integrated pilot program, which seems to be a sort of fast track towards regulatory capture in the United States. I mean, that seems to be quite an interesting topic at the moment.
Hmm.
Um, yeah, okay. Hopefully, Jack, I've addressed your question in a fair amount of detail. So, Abdul Basit asks if there are any relevant findings or insights so far regarding the democratization of new theoretical and experimental models in eVTOL development for enabling effective collaboration across industry, academia, and the regulators. So, sort of drawing the whole piece together, where we include the sort of modeling aspects through STPA through into operationally sensible information which can be implemented.
I don't think we found any evidence. Well, other than we were very pleased to see the Cap 4141 come out
Mhm.
because that well, it's a really good piece of work and a lot of time went into it, and it came up with some really stunning results. But so people are producing roadmaps. People are doing some elements of some of our recommendations. So our recommendations were like, what's best practice? What should people be doing to
Mhm.
ensure systemic safety? So we had little bits of evidence of it happening, but nowhere is it all happening,
Mhm.
because that's why we thought we felt we needed to make the recommendations. Um, STPA is being used in academia. I saw a great one for an airport or series of airports in South America,
Mhm.
to do with pushback and ramp and terminal activities. Um, but so I haven't um, seen that being used
It's a pull through, so to speak. Yeah.
outside of that, yeah.
Mhm.
But I mean, some of the working groups that we saw within their setup, the people on it are striving for effective communication and making sure what they're doing. But that's their little silo. What we're suggesting is all that kind of activity should be coordinated from a central integration board, and uh, that little subgroup acts as feeding into the main one. At the moment, it's just too fragmented, I think.
Mhm. Mhm.
So that's what led us to make the recommendation. I think most people on an individual level are keen to do the right thing and are keen to
I'm sure
share
they are.
information and make progress. It's
Mhm.
just having that infrastructure to fit into to do the right thing, I think, is
Mhm.
the issue.
Which again, Gordon Willie raises a very interesting point, and he says that the key to all this is getting public and local authority acceptance of this novel and highly proximate air transport sector. And he suggests that this should start now with publicity for this initiative and careful briefing of the non-specialist press.
Mhm.
And yeah, I think we can accept that, can't we? The question is, do you have the energy? Do you have the initiative? Do you have the staying power, if you like, to actually take this out on the road, to to actually get the right people knowing about this, to get articles written up in the non-specialist press, to kind of start a campaign perhaps even.
Well, it's definitely my new hobby,
Mm,
because I've been quite enthused by this particular topic and this particular way of looking at it. I mean, to be honest, I've really enjoyed going back to being a student again. It's
mhm.
with the exception of writing long essays. But you know writing essays is a task you have to do to get your message across. So it's you know, I might not necessarily enjoy it, but it's definitely a thing you have to do. And yeah, my current role with Virgin is to do with fatigue risk management. It's not this entirely, but
Mm,
Virgin is selling seats on a Joby flight that isn't happening yet
mm.
to bring people to their business class flights. So there is Virgin are on the EVSLG as well. So uh, yeah, I'm keen.
Okay, good. Yeah, and I think you've got a bunch of supporters behind you here to a large
Good,
extent.
good.
Gordon does amplify his point. He says, yeah, that sometimes the crossed wires don't necessarily take place between the actors within the technology themselves, within the community. It's more when that community tries to interact with the outside world. So yeah, I would my advice would be to enlist the help of folk who are, you know, who have gone through this mill before, who've seen their reports on the outwash. I'm talking about the FAA now, you know, on the outwash below helicopters exceeding hurricane force winds, when that's a complete mischaracterization of effects and so on.
Hmm.
There's an element of public communication involved there, which
Yeah,
can
and
be a bit
yet
daunting at times, I guess. But yeah.
the public communication we are getting at the moment involves smiling people with not a hair moving as the aircraft lifts off right in front of them.
Absolutely. Yeah. There's
So
that. Yeah.
there's mixed. Well, there's a wrong message there that's happening. So that needs to be corrected.
Mm. Yeah, no, exactly. It's getting the educated message across rather than the extremes.
Hmm.
And I think in this particular domain, we've seen for a long time that both those extremes tend to dominate the discussion. Hence again the motivation for what you're doing here and now. Um, yeah, Alan just emphasizes the idea of TCAS as well. He says, yeah, I think it's one of the most interesting physical problems, this segregation of trajectories and so on within the eVTOL stroke AAM world.
Hmm.
How, if we are going to be talking about operations with multiple vehicles per hour, if not per minute, do we actually start to segregate these vehicles properly and physically? So yeah. And he mentions the idea of buildings, multiple landing sites all busy interacting and interfering with each other and so on. So yeah, it's an interesting physical problem, I think.
Yeah, and complexity is a challenge in itself, and we're just getting more and more complex with our things. So
Mhm. So Paul Fennessy asks a question which I'm having a little bit of trouble in interpreting, but he is interested in the concerns around the design space and how this became a recommendation with the relationships. I'm guessing he means how do you actually configure a system given the recommendations that you have? Is there a feasible, okay, you've got a bunch of recommendations which are fairly high level. How do you actually deconstruct those recommendations into actionable elements, which will then emerge as an infrastructure?
mm. So
Quite easy
um,
to sort of sit on top and make recommendations, but how do we actually bring this into reality?
yeah, so the idea is to make them practical and applicable, and as I hinted with the one to do with the OEM regulator relationship, is that it needs to be workshopped with people involved in the industry, and I think that might be is that the design space he's talking about with the manufacturer and how
I,
this.
I'm wondering, maybe
Yeah,
Paul, you'd like
but
to elaborate
oh, okay.
Yeah, yeah. Hello, good evening, all.
Hi.
Hello,
on you go,
hi.
Paul.
Yeah, Yeah, no, definitely. That was sort of my focus area really was how did you come across those concerns with the OEM, and yeah,
Right.
how did it become a recommendation?
So it came out of the thematic analysis of some literature and some of the interviews we had, because we did interview a fairly major OEM and quite a few regulators. And in our discussions, our questions with them, and looking them in the eye, um, we did generate some evidence that uh, here in the UK, we maybe have some concerns about how things operate elsewhere. And so they had evidence of bad practice and they had suggestions about good practice. And uh, our conclusion from that evidence was that, well, wouldn't it be easier if there was a set of um, terms of rules of engagement, and then people would know where they stand and people would know um, how to do this relationship, and there will be no non-transparent activity, shall we say? But in order to get the nitty-gritty, I think a workshop with parties involved, and that okay, shall we say this? No, well, that stops me doing this particular process, or um, uh, just just creating a rule set that people can work by and be productive and be symbiotic and learn and grow and allow innovation, but include regulation. Does that answer the question?
Yeah, no, it definitely does. No, thank you. It's yeah, really good. Yeah, I work for the UK CAA, so I'm an airworthiness surveyor
Well,
within the sort of manufacturing world.
yeah,
So yeah, it's the reasons why I asked that question.
yeah. So, when you're looking at new products, people doing things in different ways, how do you ensure that you're allowing them to do new things, but make sure you're not allowing them to do stupid things. And how would you feel if they said, um, well, if they tried to persuade you to something that you didn't particularly want to do?
Yeah, and it's a very good question, and from sort of my side of things, we're seeing um, people coming from the aerospace, from the automotive background, because the technology it is there within automotive, and they're bringing it across to aerospace.
Mm.
So I think it's just sort of reminding them of the regulation that's there,
Mhm.
especially between design and production.
Yeah,
There is the arrangements there that each other have to be talking closely together,
yeah, yeah. So,
and
from that angle, there must already be some sort of rules and regulations about what you can
definitely.
and cannot do. So
Yep.
maybe our recommendation is that, well, let's take this and evolve it into what we need.
Yeah, no, definitely, and that was really the reasons why I wanted to sort of delve into that and find out deep dive like why I asked the question, because
Hmm.
there is rules there already, and it's just
Hmm.
finding out right what are they struggling with
Yeah.
out there.
We did also see some evidence about people having to be translators in between people using aviation language and people using the language of Silicon Valley. And uh, because there's a tech influx into aviation,
Yeah,
people were using terms to mean different things, and it caused a bit of confusion. So, in that respect, the relationship, yeah, you need to be speaking the same language, and that was another sort of issue uh,
definitely.
we thought was quite interesting. We hadn't really thought about that angle until it came up in the data.
Yeah, yeah. No, thank you very much. Thank you.
Yeah, good question, Paul. Thank you. Um, if I could question back, you mentioned the automotive industry, and I wasn't quite clear whether you thought that the influx of automotive ideas into the aerospace industry was an overall positive or negative. I'm guessing it's somewhere in between. But are you implying that the automotive way of doing things when imported into aviation has caused problems, or are you suggesting that the automotive way of doing things has something to offer to the aeronautical side of things?
Yeah, no, it definitely has a lot to offer. It's just I think there's a little bit of training on the regulation that is there. It needs to be followed, and they do need to be compliant when they're doing this innovation. But I think once the understanding of all that process is there, I think it will work really well.
Mm-hmm. Yeah, no, I think this is one of the great things of the electric revolution, isn't it? It's actually enabled such a, maybe I shouldn't call it a democratization, but certainly an expansion of accessibility to the industry. And we can tap on the resources of a number of different fields that perhaps even haven't been considered as aviation related in the past, and learn from these folks, bring them in, make the system safer, make it more flexible, make it operationally
Yeah.
more efficient, whatever it might be. So yeah, I mean, what that kind of means is a bit of a note to self and a note to the folk on the call. It's, if you know somebody who can talk well on that area, and we can learn a little bit more from folk that are well outside the classical aero domain, let's say, let's have them on. Let's listen. Let's see what they have to tell us. I think we'd all learn something.
I guess a note of caution would be that the manufacturing quality of things for the car industry and aviation industry might be different. I believe the first air accident report from the Wright brothers, when they used the wrong kind of wood for a replacement propeller, and it split during the work, and obviously it caused a fatality. A piece of wood that would have worked in another situation didn't work in the aviation environments. So obviously needs to be some caution in that
Sure.
respect.
I think I always quote Donald Rumsfeld and his unknown unknowns, right? It's to a certain extent, there's a tremendous amount of legacy material within certain of the aeronautics domains.
Yeah.
The one that I always bang on about, of course, is helicopters. That there's no need to reinvent the entire drivetrain of eVTOL aircraft, because quite a lot of knowledge is actually embodied in helicopters. And we've seen specific instances where lack of that knowledge of the unknown unknowns, if that makes any sense, has actually led to delays, problems, accidents. So yeah, I take your point. We do need to be a little bit careful to filter information which comes our way. But that's what we do as engineers, scientists, and technical folks, is not.
It is.
I think we should start to think of wrapping things up. But let's just Abdul Basit has reminded me that we haven't talked very much about the international aspect of this in much detail. So you remarked that your study ended up by default essentially being confined to the UK, although you tried your hardest to get input from folk in Dubai and Poland. Now, to what extent do you think we should be careful in looking at UK conditions and extrapolating more broadly to the rest of the world? Are there unique features of what we do, what the topography is like, what the climate is like, what the regulatory topography is like, that we need to bear strictly in mind if we start proselytizing these sorts of ideas out more broadly than the coast around the island that we happen to live on?
Yeah, absolutely. That was high on my list of caveats. But as I say, we did feel we had to start somewhere. But clearly, seasonal environmental differences do cause the different effects. But I'm assuming that you can put those into design tolerances and things like that, in terms of this area is particularly hot and this area is particularly cold, so therefore we can't do exactly the same thing. But you can create procedures for when something is particularly cold, and procedures for when it's hot. So it's the cultural things that I think are most challenging, because that's people, and people are the big variable, because people will be enacting the recommendations. So I think I'm going to go back to best practice is best practice, and if we think this is the way to do it, I mean, otherwise ICAO couldn't exist. Nothing it said would be applicable to all the environments that that ICAO recommendations are used. So there must be a way of changing things, and I think it's back to our recommendation is adopt global things unless there's a good reason not to, and then you document that reason and you are transparent about it, and you say I don't know, I mean, there could be, say, everyone, there's a population where no one's taller than 4 foot, therefore, a rotor blade doesn't have to be low down on the ground. But obviously, that's a disaster somewhere else. But so you'll say, well, we'll have a lower blade, and that makes it cheaper. And we'll all know that, and we'll make sure we don't buy their product. It's that side of that sort of transparency, I think, is important. If there is a reason to change, then that doesn't stop the change, but we need to know why and what that change is.
Makes perfect sense. Thank you, Stephen, for a very, very interesting hour and a half that it's turned out to be. It's been a pleasure having you. You've made a fine start to the series, and I hope folk on the call have enjoyed that discussion. If we can, we should give Stephen a round of virtual applause.
Ooh,
and there we go.
thank you very much. I'm touched.
And just to wrap up, let me give you an idea of future arrangements. So the next in this series will probably be held round about the end of May-ish. We're still looking for a speaker. If you'd like to recommend someone, then please go ahead. Why the next talk is going to be at the end of May is that at the end of April, the Rotorcraft Specialist Group has one of its annual named lectures. This is the Alan Bristow Memorial Lecture, which will be held at 4 Hamilton Place. That's the RES headquarters in London and I'm just looking at my calendar over here, on the 28th of April in the evening. The details are on the website. You'd be more than welcome to join us, and that'll be an in-person event and a little bit of discussion afterwards, hopefully along the same sort of lines as we've had this evening. So the next talk in the online series in about 2 months' time, and we'll look forward to having you then. Please get in touch with me if you have any speakers that you'd like to suggest, or if there are any comments that you'd like to pass on to Stephen. I'm sure that he'd be very happy to field them. And I guess the best place to find us is probably on that dreaded social media platform that we call LinkedIn. That's pretty much linking as it does. Good. Okay. Thank you, Stephen. And good night to everybody. We'll call off there. I noticed that Correa de Sa has asked if we can share an email. And let's see, let me just interpret this question a little bit. Yes, get in touch with me via LinkedIn. That's probably the easiest, and I can act as the nexus for distributing questions or contacts from there. So that's probably the best way of doing that. Okay, we'll stop recording and we'll say goodnight, and we'll see you all next time. And thank you again to Stephen for a very entertaining talk.
Thank you.